everyone, today we're going to have a look at the expansion of perfect squares and the difference of two squares. But first of all, we're going to zoom in into the expansion of a plus b times c plus d. Afterwards, we're going to have a look at the expansion of perfect squares, and last but not least, the difference of two squares. An example of the expansion of a plus b times c plus d is as follows. So we have 5a plus 2 times a minus 3. When we use the FOIL method or the banana method, we do 5a times a, 5a times minus 3, 2 times a, and 2 times minus 3. What we get is 5a squared minus 15a plus 2a minus 6. We can highlight our like terms. And remember that that something is a like term when the letter is the same, so in this case the a, but that also the power is the same. The minus 6 doesn't have a letter, so that's just a number, so it's not a like term with the a's. Minus 15a plus 2a are the only two like terms, and the answer is minus 13a. So this is your final answer. If you need to simplify x minus 1 times x squared minus 2, you're going to use the banana method again. So x times x squared, x times minus 2, minus 1 times x squared, minus 1 times minus 2. What you get is x to the power of 3 minus 2x minus x squared plus 2. Again, highlight the like terms. As you can see, there are no like terms in this case. And then we need to make sure that everything is in the standard form. Remember that the standard form is with the highest power at the beginning and the lowest one at the back. So we get x to the power of 3 minus x squared minus 2x plus 2. This is your final answer. Well, let's now have a look at the expansion of perfect squares. We're going to simplify 4b minus 3 squared. That's where the perfect squares come from. We know that when something is squared, that it's multiplied by itself. We know, for instance, that 3 squared is the same as 3 times 3. And 4 squared is 4 times 4. So 4b minus 3 squared is the same as 4b minus 3 times 4b minus 3. We're going to expand the brackets again. So 4b times 4b is 16b squared. 4b times minus 3 equals minus 12b. Minus 3 times 4b is minus 12b. And minus 3 times minus 3 equals plus 9. Again, highlight your like terms. And you can see that minus 12b and minus 12b are like terms. So what you get is 16b squared minus 24b plus 9. The next question is m squared minus 2 squared. That's the same as m squared minus 2 times m squared minus 2, since we multiply it by itself. Again, use the banana method or the FOIL method, and you get m squared times m squared is m to the power of 4, m squared times minus 2 is minus 2m squared, minus 2 times m squared is minus 2m squared, and minus 2 times minus 2 equals plus 4. Again, highlight your like terms and you can see that the answer will be m to the power of 4 minus 4m squared plus 4. There is a rule for the perfect squares that it works for all of the perfect squares. And it's as follows. We have a plus b squared, and that's the same as a squared plus 2ab plus b squared. You may use the rule, but it's not necessary. It's not a must. You may always just expand the brackets so that you're really sure that you have the correct answer. Well, now let's have a look at the difference of two squares. I will show you two examples. Simplify. First try yourself, so pause the video and then watch if you did correct or not. 5k plus 1 times 5k minus 1. What you do is 5k times 5k, 5k times minus 1, 1 times 5k, and 1 times minus 1. What you get is 25k squared minus 5k plus 5k minus 1. When you highlight the like terms, you see that minus 5k and plus 5k are the like terms. Minus 5 plus 5 is 0. So minus 5k plus 5k is 0 as well. We do not write 0 down. It's just 25k squared minus 1. The last example is x minus 3 times x plus 3. We use the Banana method again. So x times 3, minus 3 times x, and minus 3 times 3. Your answer is x squared plus 3x minus 3x minus 9. Highlight the like terms. And again, you see that 3x minus 3x is 0. So they cross each other out. And therefore, your answer is x squared minus 9. There is a rule again. The difference of two squares, so a plus b times a minus b, is the same as a squared minus b squared. And we can perfectly see that in the examples as well. Since if we go xa and minus 3b, xa and 3b, we see that we have x squared as answer, and 3 times 3 equals 9 with a minus. And that's what the rule is about. Again, you can choose to use a rule, but it's also perfectly fine if you just expand the brackets and do it the way I did with this presentation. If you have any questions, please let me know. I really hope that you had the correct answers.